I thought this was the most fun panel. One in the back. David.
Dr. Peister, the moat technology, I think, is a very exciting technology. I'm wondering what sort of research and what developments there are in the area of quality of service. I mean, when you start talking about patient monitoring, time-sensitive communications are very important. And in an adaptive technology like that, the old classic route loop problem, where you have jitter, latency, and delineated quality of service degradation, what kind of can we anticipate there in those areas?
It's an excellent question. The reality is that with wireless communication, you cannot guarantee with 100% certainty that you can deliver a given level of quality of service. However, given that limitation, for example, if the United States military wants to prevent you from communicating with wireless, they will. Right? We have the ability to do that. In that context, though, or given that reality, you can throw an awful lot of technology at making this wireless communication extremely reliable. So the industry where there's actually some real adoption that I showed you, the oil and gas industry, this is being put in control loops in oil refineries and chemical processing facilities and things like that have the same kinds of strict latency requirements, and there are serious financial repercussions if you miss those latencies, because they have to go into an emergency shutdown if they don't get that packet in time. And so the result is that there's been an awful lot of effort that's been put into doing reliable, time-bound delivery of packets in these networks. So it costs you some power, but not so much that you can't do it on batteries for years still.
Other questions?
So another example, one of the areas, GE Sensing is shipping a pharma product for monitoring the manufacturing of pharmaceuticals. And they're in production, it's being installed, or it is installed in a growing customer base. And there, if they lose a single packet, they have to throw out the entire lot that's being manufactured. And so they have spent a lot of time verifying that this technology actually does give them the reliability that they need. Now, that's not latency sensitive. They've just got to, by the end of the multi-day run, they've got to have all the data. But it is a reliability spec.
Other questions?
First of all, thank you all for running on time, because as you can see, when I was moderating, the sessions ran an hour late. Christian and Carol, some of the presentations this morning were on microneedlework, on newer types of visualization, PET MRI. Do you, from a zoonosis and veterinary school aspect of it, do you all have need for these types of technologies? Because we don't see CITRIS as a whole hasn't done any type of collaborations with veterinary school, and I think it's an interesting area for CITRIS to move into. And can you just talk about what interest you all have in that field, or in those fields?
Maybe I can start. I think it's important to understand that we have kind of a split in veterinary medicine between individual animal care, so the type of care that you would give to Barbaro, the racehorse that broke down on the racetrack, versus the type of individual animal attention that, say, any of these chickens in the pictures got. An agricultural animal is treated as a member of a herd or a flock. And so things like, things that would translate directly from human medicine into veterinary medicine would transfer into the individual animal care side. So we have a teaching hospital, and I'm sure there's tremendous interest there. So I come from the ag animal side as a poultry veterinarian, and so on a populational level, we fit more with some of the technologies that people have used for biodetection, or the sniffers in the subways in Washington, D.C., and the bioterrorism types of technologies. And a lot of those have been translated into agricultural animal species. But I think it's important to remember that, when we're talking about emerging diseases, we're talking early, the earlier you're looking at the transmission from animal to human, the more rare the case is. And so the more sensitive the technology has to be at detection. And as you get further and further along, it becomes much more difficult to stop, an emerging outbreak, but it becomes much easier to detect. And so we play this game at this interface of, right now, Christian and we've just put out a paper that, we're suggesting to do bird monitoring as opposed to human monitoring for highly pathogenic H5N1. So avian influenza coming from Asia. Why? Because it would be much more prevalent and easier to find in the birds as opposed to the humans. So I think it's this balancing act of, when in the outbreak do you begin to switch? And some of the technologies I think we're talking about would be looking at detecting very, very rare events, and, might be hard. Probably they haven't been thought of yet.
The only thing I have to say is on the human side, those rare cases often take time. And, like as Javeed knows, when you're an ID doc, you have to draw serology. It sometimes can take, weeks to get an answer back that you feel comfortable with. Anything that can move that up a little bit quicker is going to be liked. The problem is, again, they're rare diseases. So these are not, everyday things like cholesterol or, blood pressure medicines. Again, it's rare stuff, but could be certainly applied pretty quickly with that.
Other questions?
Hi. My question's about the voice sensors. If you have the sensors in a room, like in the environment, and you have multiple people in the room, how good are you at distinguishing between the voices of different people?
It's possible to do speaker identification from voice with the technology that's similar to speech technology. So it's in that layer that's above the features that we're looking at right now. So that would become important if we had that situation. If we had, say, a household where there are several people and we're trying to keep track of each one. So it's I would say it's something we have to worry about. If I recall, the accuracy with off-the-shelf technologies is not too bad in a well-controlled microphone situation like this. What probably hasn't been explored much would be when you have microphones sort of distributed around the room and people are just talking and there's room acoustics that are all over the place. I don't know how well the speaker ID would work there. So that's one of those things we would definitely have to worry about. So I don't know what the answer is. There's certainly a technology base we could try to build on, but I think we're still being new ground.
For the hazmat suits, are people trying to put in water-cooled ventilators of some, or water-cooled fins?
No, and mainly because they're disposed of afterwards, so people just haven't gotten as interested in that. I mean, I think there's some smaller techniques, but not entirely. No, they've gotten obsessed with making them completely impermeable, which then becomes an issue with overheating and other things like that, and I think you're now moving towards the other side, but not to any great degree, no. I mean, you see, that's why I enjoy Hollywood, where you see these guys running up and down the street in those level A scuba suits, which you need about 3 years of training just to put them on so you don't pass out and harm yourself and suffocate, literally. So I always find entertainment as they run up and down the street. But sadly, there's not any, if you can have a mechanism where that technology is preserved but the outside of the suit is disposed of, I think you'd have pretty great use. California, we spent, I don't know, probably now close to about $10 or $12 million in the last few years on those disposable suits. So you can imagine there's a pretty good market for it, and it's now going to be required in all healthcare facilities. So.
I just wanted to mention along those lines, there's been some fairly recent DARPA-sponsored research on cooling soldiers' core body temperatures without, complex, fins and cooling and motors and so on. I think some of this work was actually done at Stanford, and looking at sort of like a surprisingly simple system that can significantly pull off core body temperature. So that might be something, and it's basically a vest you wear. So that might be something that could be used in those cases.
Fortunately, I hate to tell you how long DARPA initiatives make it out into the veterinary world, but but yes, it would be good. I actually have a question about the voice recognition. And so someone mentioned that the vital sign monitoring was not of interest initially. I think your first slide, you said they thought it was the short term of that was not of direct interest.
Yeah, we've got a lot of sort of lukewarm reactions from physicians about if we really had this, what would we do with it? Because they have enough information to deal with right now, and they have to record. You know, they're to in a certain extent overburdened with information right now, and they need to record information and annotate every step they do. With every new piece of information they get, there's additional liability. You know, was there something in your 500 hours of monitoring traces that indicated an oncoming stroke? And if there was and they didn't act, then there's usually a repercussion. So they're not looking forward to dealing with this essentially fire hose of data in the short term. In the long term, yeah, and other actors in the space, insurance companies and especially people in the elder care space are very interested because somehow, for elders, for instance, the level of risk is going up, of something happening at random, without warning is much higher. And so it makes more sense there. But no, there's definitely an incompatibility between this new kind of monitoring, as with any prophylactic monitoring, and the system that we have right now.
Yeah, you don't want monitors for lawyers, are bad. But the one thing which I actually disagree to extent on that is this idea that in emergency medical services we do something called start triage, which if you have a large train derailment and you have 100 or 200 people to go through in a minute, there's a quick triage mechanism which actually involves vital signs and just cognition, and it's very rapid. The problem is you have to repeat it on a serial basis. So if you go through 100 people and you weed out 5 that are critically ill, you now have 95 that have to go through it on a regular basis. I think your device would be wonderful. If you could put this on and have them, repeat some voice recognition or cognition, if they fail at any point, it alarms, and then you can notify that person. And that's a short term, in the field, because that's one of the extremely difficult things is you can maybe triage people up front, but it's that second or third or fourth layer as you're evacuating the more critically ill, and you ignore those people where it might have a big role in that. And, there is a lot of data now coming out. Actually, there's a paper just published this month that either under triage or over triage in the field, medical field, both leads to mortality. So if you pick up too many people and ship them in the hospital, that's bad and increases mortality. But if you're a little bit lax, obviously, that'll increase mortality. So getting it right, there's been more emphasis on this. So it's
It's a good area. We haven't just encountered that before.
Yeah.
It's a good thing to look at.
Yeah, EMS. Right now it's a person checking a card off and putting the tag around their ankle, and that's it. So.
I also made an oversight. Stefano, I mentioned that you would be on the panel. You're still welcome to come. We still have. I have one right here. All right. So, any questions before we go? Actually, we have a little bit of time. Any questions? Any more questions? Do you have? All right. So, thank you all for participating, and we'll close the panel. Thanks again for our panelists in the New Frontiers.
I hear you more than coffee, Dan.